All right. So tire industry webinar. We at Samson Controls have a lot of experience providing block valves and control valves and some specialty technologies to the rubber curing industry. Typically, it's easy to say tire industry because it's predominant compared to other industries that take rubber and mold it into something different, like rubber hoses, belts, and such as that. But typically, tires are the predominant verbiage being used. So you'll see me in my presentation. I'll go back and forth between tire cure and rubber cure. But all our technologies that I'm going to present and roll out is going to be will apply equally. So for those again. Who I am, my introduction, my name is Joe Milam. I'm the key account manager and a regional sales manager for Samson Controls. I have a couple of key accounts that I call on globally and domestically, but I'm kind of morphing a little bit into a tire and rubber curing specialist, but please do not call me that because I have still a good bit to learn, but within 5 years, I've been embedded into some tire plants. I've gained a lot of knowledge. So that profile picture of me right there, it's not exactly me. That was a couple years ago. I've kind of aged a little bit since then. Then my counterpart, Matt Moyer, he's our IoT and integrated system, or excuse me, our system specialist. He's based out of Cincinnati, Ohio. So again, him and I are going to be swapping off back and forth between the various slides here. Like I said, we're going to try to keep this as short and sweet. This is going to be a quite high altitude overview of the various process applications in a curing industrial manufacturing environment, and then some of our products and technologies that are a very good fit. Now, we have a lot more other technologies that we can talk about. That would take about 4 hours of everyone's time. So we're just going to keep this real basic here. In other words, meat of the matter. So this presentation is not to learn how to cure a tire. It is simply going to begin again a overview of the best fit Samson valve actuator and associated related instruments that go for into these type of industrial manufacturing environments. Matt, you want to go ahead and tell a little bit about who we are for those that are not as familiar with us as we are?
Matt? Yeah, so okay. I'll just have to rely on you to click the presentation forward.
All right.
So as you can see here,
well,
you're given the presentation then.
Okay.
So
yeah. Okay, gotcha. All right, go ahead.
So as you can see, Samson Controls, not only have we been making control valves and regulators for the process industry, but we also take it a step above and we're making actuators to or digital solutions in terms of positioners. So in terms of control valves across all industries, you could think of it as anything from lined butterfly valves, but in terms of specifically for the tire making industry, we make a lot of steam regulators and control valves, also anything for tight shutoff in terms of nitrogen or any other process gases that you would be using in there. And then we've got a wide range of solutions in terms of the positioners to I to Ps, solenoids, limit switches, all made by Samson. You want to the next slide, Joe?
Yeah,
and so I kind of mentioned a little bit before, we are all in all industries. The ones that we're strongest in would be food and beverage, pharmaceutical, chemicals, industrial gases, steam, and then situations with tire making applications. So next one, Joe. So a little bit of background on Samson. That up there, the picture that you see in the right and in the bottom right over there are the Samson Controls actual site in Germany. So that's our headquarters for global. And Samson itself, a 100-year company, over 100 years. It was founded in the early 1900s in Mannheim, Germany, and it grew up in the chemical industry. So specifically, a lot of the big chemical manufacturers that are German, the BASF and the Bayers of the world, moved to Frankfurt in the early 1900s, and that's where we're actually located now. So that's where we have our R&D, production, sales, and there's about 1,600 employees globally there. On to the next one, Joe. So what's really nice about and what you see here is the Ralph Sandvoss Innovation Center. So that was recently opened in 2018 where they completed construction on it. And I can tell you that this is unique in the industry. There's not many other control valve manufacturers that are putting the much time and resources into still innovating. And it leads to us coming out with new positioners that we'll talk about and also new control valve designs. So we're constantly looking to innovate. So when you're partnering with Samson, you know that it's not going to be relying on old technologies. So go to the next one. And then this kind of gives you a little bit of overview of the different types of stuff that we do inside of that. So you can see there's 24-inch globe valves to life cycle testing. So you know that we're trying to get the maximum lifetime out of these control valves in your process. So they're always being tested. Next slide, Joe. And then these are some of the offices that you'll see around the world. So if you're a global company that's manufacturing tires in one country to the next, you don't have to worry about support because we've got you covered across all areas of the globe. So specifically what you see down there in the bottom right-hand corner is our Samson Baytown office, which is where we are in North America. The next slide. Yeah, and then you can see these are all the sales and staff areas that we've got, the production sites across the globe. So a lot of different industries and a lot of different sites. Turn it back over to you, Joe. Oh, and then this is our Samson Baytown headquarters. So we completed the manufacturing production facility that you see there on the left-hand side in 2015 or 2014, actually. And then over there on the right-hand side is where you'll see our engineering and a lot of our kind of corporate accounting is over there on the right-hand side.
All right. Okay, in the tire curing facility there, you're going to have two different types of press machines or molds, some people will call it, that you'll find a lot of opportunity for our products. And one's going to be a mechanical press, which is seen on the left-hand side, and on the right is going to be your hydraulics. Pretty much the industry has moved over to hydraulic press machines. They're much more, much better, much more automated, much more efficient, and cures tires more quickly and with less scrappage of tires as well. But even though mechanical presses have not are not obsolete, there's hundreds of thousands of these machines worldwide, various curing tire or curing manufacturers. So and there's a effort in some of the companies that I call on to mechanize or retrofit the mechanical presses to where they are getting to close to the levels of quality production output as a hydraulic presses, but it comes at a cost. And we're having a lot of success with not just putting brand new Samson valves and actuators and instruments on brand new hydraulic press machines, but we're also doing them for plant level mechanical press machine retrofits. For these curing press machine, the process mediums to cure or cook a tire is going to be low to medium pressure steam. When I say pressure, medium pressure, probably up around 400 psig saturated steam. But there'll be some facilities in the world that will also go up to maybe around 500 psig on saturated steam. Nitrogen is becoming extremely common to be a not completely as a substitute to steam, but as a combination to cure tires more quickly and more evenly, more efficiently throughout the globe. And then you got condensate, which is a part, not so much part of the curing, but it's just a byproduct of the decayed steam that's within the tire press machines whenever it's going through its cure cycle, which can last anywhere between, depending on the size of the tire, it's going to be anywhere between 10 to 20 minutes on average. So those are the main items for steam, nitrogen, and condensate. That's what we go after. Can we do plant air? Yeah, we can do plant air, but that's just not going to be a big thing in the curing industry because it's typically commodity ball valves sitting in their storeroom bought by dime a dozen. Typical curing processes, of course, they got pressure and they got temperature that's coming from their boilers to the steam headers going into the tire press machines, but it's typically based on temperature in which the plants are using to cure or cook their tire to the exact specifications set forth by that particular rating and size of that tire. And I've come to learn in a short period of time around 400 degrees F at around 400 degrees PSI is going to be the average pressures and temperatures. Again, pressure is important, but the Fahrenheit really is what one engineer told me, pun intended, is where the rubber meets the road when it comes to how they cure their tires to the exact specifications. Other areas of a curing facility that is very that we target is going to be steam headers because the steam typically coming out of the boilers are going to be too great for the tire press machine, so they got to have letdown stations, distribution centers, such as steam headers, steam distribution centers, the boilers themselves, and then of course what we already discussed, the tire press machines. Typical sizes for on-off and control valves are going to be 1/2 inch through 8 inch. They can go larger, perhaps, especially when it comes to the chillers or the chilled water systems in the plant. They'll go from 12 to 20 inch, and then they're cooling towers. But those are not high turnover items. They don't wear out very quickly. So typically go after the smaller sizes on the more severe applications, nitrogen steam and decayed steam and condensate. Standard pressure classes I've seen is going to be around ANSI 150, 300, then 600. When it comes to the controlling aspects of how they take this layered rubber, then they form it into what looks like a tire. It's called a green tire. Now they got to put it into the tire press machines, and they've got to regulate how much steam, how much nitrogen, and how much decayed steam and condensate leave the tire press machine. So the typical type of control valves out there on these tire press machines are going to be some your standard rising stem rolling diaphragm glow valves, sliding disc valves, wide pattern piston valves, and I've seen even just pressure regulators that were operated by remote I2Ps. The type of control valves on the curing press machines, when I say type of control valves, we're talking specific process applications within the tire press machine. So when you're looking underneath the tire press machine, you see this spaghetti junction of piping, valves, tubing, fittings, a conduit, and such as that. They're going to have, each pipe is going to be dedicated for a very specific function when it comes to curing a tire. So when it comes to control or modulating the process mediums, which I said was going to be steam, nitrogen, and decayed steam / condensate. Common terms are going to be internal steam supply, external steam supply. That's actually going to be where your molds are at, where they're heated up, and then the bladder, which inflates inside the tire itself to press it outward against the platens and the molds. And then, of course, critical drain controls. If you don't vent out, if you don't drain out your decayed steam and or condensate efficiently, then you're going to have irregularities in the temperature set point for curing that tire at whatever stage of the curing process. When it comes to let's just say the boilers and utilities, the very common control valve application is going to be boiler feed water recirculation, steam supply to headers, and steam headers to letdown stations. Of course, there's always going to be a few other items here, but that's going to be the main controlling applications for a tire plant. Now, when it comes to controlling across the board, we have a very broad portfolio of control valves. We start off with our 3522. It's called our Little Tex because it's made in Texas, and it's the little brother of what you see is the 3241 highlighted in the battleship gray. And then you got the 3251 and the 3291. Those four right there, model numbers or types are going to be where probably 90% of any of our control valves are going to be the best fit anywhere inside a tire curing facility. When you start getting up to the 3595, and 3591, I think that's going to be some pretty rare and exceptional circumstances here. So I'm going to run down a little bit of an overview of the 3241, 3251, 3522 as well. All right, so the Little Tex, we're having a tremendous amount of success with installing these on, again, on the controlling aspects of cure and press machines. It's cost effective. It's a very short height profile and weight because space is a premium underneath a tire press machine. If anyone's ever spent much time on some of the older mechanical presses and some of the newer hydraulic press machines, you've got to do the mambo to get underneath the press machine to access any valve under there. Some press manufacturers have the luxury of trenching out a hole in the ground and then dropping a machine on top of, and you got a lot of walk space there. But I haven't seen too many of those. But the Little Tex is our, if you want to call it, it's more of our commodity driven, price driven, but yet it's still high integrity, very robust control valve. And it goes from half inch through 2 inch. Comes in stainless steel, class 150 and 300, typically 300 pounds, what we're seeing in the tire industry because of the higher pressures coming out of the headers, dropping down to around 400, from 600 to 400 pound PSIG. We got multitude of flow values and flow characteristics because the same type of seat ring and trim, the plug is the same that we put in some of our other control valve types like the 3241. We can go with a metal seat design with a class 4 shutoff, or we can go with a PTFE soft seal for a class 6. But you're going to be hard pressed to find a application where PTFE is going to be suitable for in the tire industry because of the pressures and their temperatures. But this one right here is right now a dominant player for the success we're having in the various companies in North America that we're selling to for tire and rubber curing. Now, there is also a need to go with the type 3241 glow valve. There'll be some applications where the press machines that may be warranted, but typically it's your steam headers or steam distribution centers and your boilers where you find that. It's a more robust design and it has more features and benefits, sizes and pressure classes and metallurgy options to choose from. So typically carbon steel 316, but we can go to exotics. This is a flange, it's or a welded or a threaded connection, various leakage allowances, and we can also put options on there like a insulation or a stem extension for very high temperature applications. And I actually have some pictures later on in the presentation that will show you where we had a lot of success in one particular tire manufacturer to where we put the stem extension on it because of the higher temperatures, and it's protecting the soft stem seals. The higher pressure, this is probably where we'll limit it out in a tire or a rubber curing facility here on most applications. The 3251, it's a very, very heavy duty, high pressure, high temperature control valve. Flange are welded in. It's just a bigger brother of the other two, the 3241 and 3522. But that one right again, it goes into a higher pressure class level, and we can put same different types of options for actuators to accessories, positioners, and trim, and into this particular design. Standard type of trim and plug seat arrangements are going to be a parabolic plug, but we can also go with a V-ported plug or a perforated plug depending on the process conditions. But if warranted, especially on steam distribution header systems and boilers where the dBA levels could be very high, flashing or cavitation are going to exist. High pressure differentials, that's when we go in and have very specialized trim. And the four that you see right here are just one of very few different engineered options we can use for a plug and a seat combination that will result in just having to use one valve, one actuator, instead of having a redundant valves to take a high pressure pressure drop scenario. In fact, the one on the upper right hand corner, that's going to be our axial flow AC5 trim. If I'm correct, Matt, the pressure drop we can take in that stage trim in one valve body is was it 4,000 pounds of pressure drop through that valve.
Yeah, I believe. Yep, you're correct.
Okay. And then all right, Matt, I'll let you continue.
Yeah, okay. Thank you, Joe. So looking right here, I want to point out a couple of interesting things about our actuators here before I go into the positioners. So when we're looking at our actuators there, what's really nice kind of compared to some of the other actuators that you'll see out there in the market is that we use a nested spring design first off. So it allows us to get a little bit more thrust out of that without needing to go to bigger, bulkier springs. So we'll just nest the springs inside of them. And it's a little bit hard to tell in there. What it's also nice is that, as you can see from that rolling diaphragm, it allows us to get a little bit more surface area without needing to make the actuator itself bigger. So we get more surface area inside of a smaller compact actuator. And then with the nested springs, and then finally we get a higher thrust because our actuator casings have a lot higher casing pressure than some of the other actuators that you'll see out there in the market. So what it results in is a nice, smaller, cleaner package that you can have that also gives you some of the highest thrusts per size in the industry. And then finally, a really great feature of it is it's also that it's field reversible. So in terms of keeping actuators or parts or stock in inventory, or if you've got valves that you're trying to adapt to other situations, you can easily switch the fail position by just flipping that diaphragm and those springs inside of there. And then because the positioner can mount directly to that, it also gives you a really easy way to take off of those positioners too. And for the fail closed applications, you can route that air internally. So go on to the next slide, Joe. So we're talking about our positioners. There's a few different options in terms of the ways that you can get them installed. So for our positioners, you can have them directly installed onto the actuator like you see over there at the right, or you can get them remote mounted as you see over there in the left. So depending on how tight it is underneath your tire press machines, or if you've got some utility piping that's way up in the air and it can be hard to get to, and you want to be able to access the positioner maybe for diagnostics features or whatever it may be, maybe the temperatures are a little bit too high, what you can do is you can remote mount that positioner like you see over there at the left. So that gives you the ability to put those positioners in a nice, easy to use place for your technicians or whoever it may be. You go on to the next slide there, Joe. So in terms of some of the technologies that we use that we're typically seeing out there around these tire press machines is that you sometimes will just have a sensor going back to an I to P that's then controlling the control valve, a sensor to an I to P to a pneumatic positioner that might give you a little bit more, a little bit better control. And then sometimes you'll just see it maybe from a PLC to a bank of I to Ps that then go out underneath the control valve. But the problem is with that I to P converter in there, maybe it's because ease of installation, or you have high temperatures, whatever it may be, cost used to be in there. Sometimes they just didn't think that they needed to be controlled that tightly. When we're getting into trying to get the most out of your tire press machines and trying to get squeeze every last tire out of there, the only way that you can really get there is by really putting in a digital smart positioner. So go on to the next slide, Joe. So we talk about our digital positioners. This is what we call the 3730. So our 3730 line, whether you have it in 4 to 20, Ethernet, field bus, Profibus, HART, and we will have Ethernet APL positioners available next summer for you. The point of it is that with a digital positioner, you're getting feedback over a traditional I to P. And in that feedback, when you tell a positioner to go to 50% open, it's going to go to 50% open. When you're using an I to P, there can be some issues that you have to tune out of it. And if you're a really good programmer or controls person, you might be able to get some of that out. But to really get to that in terms of the level of accuracy and control that you need in terms of your tire making process in today's world, you really need to go to these smart positioners. So they also offer really a lot of other great aspects too in terms of the diagnostics features inside of there. So on those critical control valves where you can't have any leak through, maybe you can use the diagnostics features to tell you when your seating surface is starting to wear. And then that easy digital communication allows you to talk to that positioner, possibly from a remote location. So it's just giving you more control over your whole entire environment. So go on to the next slide, Joe. So when we look at some of the features of the digital positioner as well, our 3730, is that it has 2 software limit switches available inside of it. And you can see a picture of it right there. It has a local interface for you to be able to initialize and set up a positioner from a local, or you could do it if it's hard communicating from your control system. Some of the other great things is that external travel pickup. You have inputs, you can do leakage sensors on there. And like we talked about before, the remote mounting for those positioners. So you want to go on to the next slide there, Joe?
Yeah, let me add a little something there. Going, with what I've noticed in some of these tire plants here, them using these older school technologies. One particular tire manufacturer, which I cannot name over this meeting here, but over the number of years, we got them convinced that they were not curing as well as they could. They thought that what they had was the best in the industry, and I guess that's their fault for not studying up on what greater technologies out there, more efficient technologies, what's the cutting trend, and such as that. Or maybe they just had some local valve and instrument and controls manufacturers that never bothered to promote it to him, but they thought they had the best of the best. And when I came in there and introduced the smart positioners to them, they realized, my gosh, how much better accuracy and product reliability we're getting. In other words, my words are, a lot of our customers out there have walking pneumonia and a bad case of it and don't even know it. And going to a smart positioner on this often could be the cure to this walking pneumonia, so to speak. All right, Matt, go ahead.
Yeah, so this slide just kind of really depicts for you guys a lot of the options that we have with these Samson control valves there. So all the way over there to the left, you could have a valve that you're controlling with an I2P if you really wanted to inside of your facility, or you could mount a positioner locally to that face. Then we've got the ability, starting from the left, looking at that one, going to the right. That one has the ability to have a positioner mounted integrally into your actuator for a little bit tighter package. And then we have the ability to add hand wheels. And then lastly, we can do options in terms of high temperatures for bonnets, putting temperatures extensions on there. And also, if you're really concerned about maybe your nitrogen emissions, we can put a bellows seal inside of there so you have zero leakage through your control valves. And on to the next slide there, Joe. I'll let you take it back over. Oh, right. Well, talking about, well, you can talk to the steam distribution system too.
Yeah, this is one particular domestic-based tire manufacturer. And they called me. It was about 3 years ago. They asked if I can replace an existing competitor's rising stem standard glow valve roll diaphragm actuator. Said it was just they've been repairing it, and it's just the leakage got worse and worse and worse and worse every time they put it in. So they said, we're fed up. We're having the success with the little techs on all their mechanical presses and so their hydraulic presses. They said, hey, we want to put a little text on replacing this one competitor's valve and header system. So I said, we can't use little text, but we can go with the 3241, the next step up. So if you take a look on the left-hand picture, on the right-hand side of the left-hand picture, you're going to see the competitor's existing valve. If it's a rolling diaphragm, rising stem glow valve, it has a standalone I2P transducer. It is connected to a standalone straight pneumatic positioner. Now, it's hard to tell. Let's see if I can get my pointer here. There is a transmitter right there. It is a temperature transmitter that's associated with that steam line, and the steam's coming from the boilers. This is their letdown, one of their letdown valves. They got various ones. So the pressure sensor is, the temperature sensor is sending its input to the I2P. The I2P is then releasing the right, so-called right amount of air supply into the positioner. Then the positioner is actuating the valve open or close or modulating. Quite the archaic makeup, very sloppy, very, bad resolution, bad response time, accuracy, repeatability. I can't imagine how horrific it is. And if you take a look at the picture on the right-hand side, that is on the other side of the header where they're using now pneumatic controllers. That's taking an input from an I2P, which is taking the input from a temperature sensor on different steam lines coming from the boiler. But going back to the left-hand picture there, you're going to see our 3241, nice khaki tan design. I was able to show them that this is a much smaller valve, even though it's the same size, same pressure class, same face-to-face value as the competitors. If we have the smart positioner or 3730 bolted directly to the bottom of our actuator, now I'm eliminating the need for that I2P. That's because ours is built in and it's all electronic. So we really cleaned things up and simplified it. So they put in about 5 in so far, and they're replacing through attrition when they need it to the competitor's valve with our 3241, and they're seeing measurable difference to their steam controllability, going down to the certain set of press machines that each steam letdown control valve is dedicated to. This particular picture is on some current brand new presses that came in, and this is where I got them standardized on the remote mount design. If you take a look on the left-hand picture where the two Samson's smart positions are at, underneath it is the crawl space where the spaghetti junction of valves are collected. And again, there on the picture on the right, you can actually see it. The multitude of on-off valves, the manual valves, automated, and our control valves. But I got them started with this one domestic tire manufacturer. They really like that concept that they can pull that positioner out, put it where it's extremely accessible to their mechanics and their technicians. Now for blocking, we are also very well versed in blocking on all applications as well. So on-off valves, block valves, whatever you want to call it. And what I've come to see over the years, typical block valve technologies is a ball valve, piston globe valves, butterfly valves, then Y pattern piston valves, and standard wedge style gate valves. All of them will work to a certain reasonable degree, but there's leakage factors that plants throughout the country, throughout the world, have just learned to be acceptable, and they having to live with the headache. They didn't know that they can get better shutoff characteristics from various Samson controls technologies. So when it comes to the cure and press machines, blocking valves are used on the steam supply to the presses, nitrogen supply to the presses, drains that protect steam traps, vent atmospheric, and then vacuum to the bladder, and then vacuum to the inlets. I mean, a lot of crazy words put together right there, but they all have a very, very important and dedicated means for curing that tire to the exact customer specifications. So on the press machines, we have gotten one of our tire manufacturers convinced that a standard floating ball, soft-seated two-way ball valve is going to be their most economical and their best fit. This company was very reluctant to try because they've been sold by many of the ball valve reps and manufacturers. Yeah, you can put it on steam. And they failed miserably, failed very quickly because it's on saturated steam, and they're very high cycle valves on these when they're curing a tire. So I got them convinced to try the Samson Starline. Starline's a company we bought out of Italy years ago. It's a very, very high integrity commodity and specialty ball valve manufacturer. No porous castings. It's all forgings or bar stock material. I mean, you look at it, it looks just like a standard floating soft-seated ball valve with a rack and pinion pneumatic actuator, which is going to be our Air Torque brand that we bought out of Italy years ago. But there's one difference that we have that other manufacturers have not been utilizing or don't have, is the fact that on the valves in question, where we're getting the reliability for very tight shutoff or very, very high cycles on steam and nitrogen and on vacuum, is that we're not using a standard soft-seated contact to the rotating ball design as you see on the one of the middle pictures, but we use an encapsulated design. We're still using a reinforced Teflon seat ring on the inlet and on the outlet of the valve that makes contact with that 90-degree rotating ball. But if you take a look in that real dark brown area where it's within the image, it says encapsulated, that is a metal, if you want to call it a casing or a container, which holds captive those two soft-seated RTFE seat rings. So what we're doing is, under pressure and temperature, that soft Teflon wants to move. It wants to, it becomes soft and becomes very, let's say, dynamic. So we're putting a measure in place that holds captive that seat ring in place to where it's moving. It's under pressure and temperature is exceptionally minimized, so we can have a consistent tight shutoff to the when the valve's in a closed position. In fact, one of the curing engineers for this company that I referred to stated that they were quite amazed that we could make such a declaration. They posted the tests on their first press machines back in 2019. The gentleman calls me up 2 days later after they started it up, this one particular set of press machines, and said that the shutoff characteristics was so tight, as I promised them before the order, that he was compelled to go back and make some changes in their PLC program and to take advantage of the exceptionally tight shutoff characteristics as we promised with our Starline ball valves here. So which means is a success. Typical types of blocking valves now on the steam and the headers, distribution centers, and boilers. You're going anything that requires isolating critical control valves, process equipment like pumps, filters, exchangers, isolating major process skids or piping packages to isolate complete loops. In this case, here's maybe a shutoff valve that will shut off maybe 20 or 30 pressure machines that one steam header control valve feeds, which is a very common design. We don't have a way of much when it comes to just standard commodity blocking valves outside of very high integrity ball valves. But when you're starting talking about very high integrity, very reliable, robust shutoff valves for severe applications on headers and boilers, we highly suggest going with the Samson Loyce triple offset, zero leakage, non-rubbing butterfly valve. So these are ideal for condensate and saturated to superheated steams, where the three geometrical offsets that you see in the middle image here is a quick pictorial saying this valve is designed not to wear and tear, as all other butterfly valve designs before they leave the drawing board are designed to wear and tear when you open it and close it as designed. But so this one right here is metal seated design, so you don't have to worry about leak through. And the fact that you got the three geometrical offsets not only gives you the maintenance free design, but also gives you many open and close cycles. All right, kind of wrapping up a little bit here. We can close the end here. Matt, I'm going to turn it back over to you about systems and piping packages. And this is something where Norm, I know that you could perhaps add some value to us with your TLV line.
Yeah, so Joe so eloquently kind of said earlier that we're really an engineering company that makes control valves. And so as part of that, we've got a lot of solutions, not just in terms of physical valves and regulators that we could supply you. You know, we have application engineers that can work with you to really understand what's happening in your process. But then we take a step further. We can provide you a whole integrated system solution for you, utilizing our products and then other products that we would use as a buyout, of course. But we have an engineering team on staff that would sit down, provide you with, whether it be engineering drawings, isometrics, that you'd be able to use as a complete package provided fully from Samson. So go on the next slide. Some of the unique aspects of those are saturated steam boiler systems. So you could reclaiming previously boiler feed water. We have a lot of different systems, condensate removal systems and collection. The next one. So that process control station are some of the options that we provided to some of our customers. So when they're looking at taking out a control valve, in some situations, they might not be just taking out the control valve where they got to put in a bypass, a block valve, because not only do we offer a lot of those solutions ourselves, but we work with a lot of other vendors to be able to provide you with PRVs, temperature sensors, whatever it may be, so that you can come to us for just a one-stop solution that you'd be able to drop in there, whether it be process control stations, steam cooling stations. On the next one, Joe. And here's some of the examples of heat exchangers stations that we put in there. And then our saturated steam system. So if you've got systems in there where you're really trying to get close to a saturated steam temperature for cooking, you know, sometimes with traditional methods using a steam conditioning valve, you really are you're limited to getting to about 10 degrees above that saturated steam temperature. But with our station that you see there on the right, we can actually deliver steam just above that saturation temperature. So it's great for those cooking applications. Go on to the next one there. And then that kind of wraps it up. I'll let Joe kind of put a bow on everything.
Yeah, that's a yeah, what an abrupt end. I probably should have ramped it down a little bit better than this here. But yeah, let's see if y'all want to, you got any questions you'd like to ask or need some clarifications or just correct me, now's a good time. If not, give me a call, send me an email, and I'll be happy to take up some time for you.